Hello guys, welcome to Aviator Guide. Let's talk about wingtip vortices today. Let's talk about the formation of vortices. The action of the airfoil that gives an aircraft lift also causes induced drag. When an airfoil is flown at a positive angle of attack, a pressure differential exists between the upper and the lower surfaces of the airfoil. The pressure above the wing is less than the atmospheric pressure, and the pressure below the wing is more than or equal to the atmospheric pressure. Since air always moves from high pressure towards low pressure, and the path of least resistance is towards the airfoil's tips, there is a span-wise movement of air from the bottom of the airfoil outward from the fuselage around the tips. This flow of the air results in spillage over the tips, thereby setting up a whirlpool of air called a vortex, as shown in the figure. At the same time, the air on the upper surface has a tendency to flow in toward the fuselage and off the trailing edge. This air current forms a similar vortex at the inboard portion of the trailing edge of the airfoil, but because the fuselage limits the inward flow, the vortex is insignificant. Consequently, the deviation in the flow direction is greatest at the outer tips, where the unrestricted lateral flow is the strongest. As the air curls upward around the tip, it combines with the wash to form a fast-spinning trailing vortex. These vortices increase drag because of the energy spent in producing the turbulence. Whenever an airfoil is producing lift, induced drag occurs, and wingtip vortices are created. Just as lift increases with an increase in angle of attack, induced drag also increases. This occurs because as the angle of attack is increased, there is a greater pressure difference between the top and bottom of the airfoil, and a greater lateral flow of air. Consequently, this causes more violent vortices to be set up, resulting in more turbulence and more induced drag. In the figure, it is easy to see the formation of wingtip vortices. The intensity or strength of the vortices is directly proportional to the weight of the aircraft and inversely proportional to the wingspan and speed of the aircraft. The heavier and slower the aircraft, the greater the angle of attack and the stronger the wingtip vortices. Thus, an aircraft will create wingtip vortices with maximum strength occurring during the takeoff, climb, and landing phases of flight. These vortices lead to a particularly dangerous hazard to flight, wake turbulence. Thanks for watching Aviator Guide. Do like, share, and subscribe.